Hello, Rob here. Today we're going to start lesson 4 back on the breadboard. In fact, I have created, for your astonishment and delight, a breadboard arena. Lights, camera, you've seen the camera already. Plenty of action. I'm going to do this breadboard all the way through. You're going to get to see it. Actually, I'll cut out the really boring parts. Okay, sorry, I lied. We're going to start on the whiteboard per section of circuit and then go back. So, for instance, the very first chip we're going to put down is the good old LM317. Then we're going to do something goofy. We're going to put it in upside down. Seriously? Yeah. I'm going to flip a couple of things around. Sorry. The first things you worry about on a breadboard are power supplies. Now you might think we only have one power supply because we only have one wall wart. Remember the little wall wart? The little wall wart. Yes, very inexpensive. Really only roughly 5 volts. It's not exactly 5 volts. There's no such thing as exactly 5 volts. This guy is pretty far off. But I'll come back to that. So over here, we start with a big old capacitor. That's really for like low frequencies, for like the vertical of the video, for the big old tank full of water. Tank full of water, yes. Why do you put capacitors everywhere? Well, you put them there for like local supplies of water. Right now I need it. I was going to say the toilet. You have a tank in the right behind the toilet, usually, that gives you a lot of water right now. Even though there's a big old lake, big old ocean, but right here I need my own little supply. And that's kind of what a power supply or decoupling capacitor does. We're going to put two kinds. We're going to put the big old electrolytic. Electrolytic tends to be, when using big power supplies, they're polarized. They got a north and a south, a positive and a negative, and you better put them in right. They're pretty unhappy if you put them in wrong. Then we follow with the ceramic disc capacitor. And really, this is going to take care of the lows, and the disc capacitor is going to take care of the highs. So everything's nice and solid. We're going to start one corner of the breadboard solid. Then we're going to add our dear friend, the LM317. And I've done something nasty. I've drawn it upside down. That's what it looks like when it's upside down. And I did it because it flows nicer. And we're using it in a slightly different way. Coming into the LM317 is the +5. Coming out, today, we want 2.5 volts. We're going to put that sucker right in the middle between the ground and +5. For sort of some psychological reasons we'll get to later. Do you hate the fact that I'm always saying we'll get to later? Do I get to later very often when I say get to later? Put it off, put it off. A fun, cool, wonderful thing about LM317 is how you set it up. I said it can make lots of different voltages. Here's how it does it. It has an in pin and an out pin and an adjust pin. Now last time you may recall we took that adjust pin straight to the ground. Okay. And what we got out was 1.25 volts. Very simple, lovely. We don't want 1.25 volts now. We want 2.5 volts. 1.252. We want twice as much. Well, a funny little rule happens. I like to remember how things work, not by the physics or the photons or the quantum level, but a general rule. If I do this, it's that. And then I can remember. And here's an example. A funny thing happens, that resistor right there, okay? That is to say, from here to here, when this thing is working correctly, is good old 1.25 volts, okay? We had brought this guy to the ground, so there's our 1.25. Now, we're gonna put another resistor here. If I put a voltage divider here, remember good old resistor in the middle type of thing? If I put these two resistors here and I have 1.25 volts across there, well, it's the same size resistor. One would expect the same voltage. Sure enough, it is. There's 1.25 across both of them. So that's a cool thing the LM set. Depending upon how you vary this resistor, as long, I won't say as long as, it will always be 1.25 here. So if I make that resistor bigger or smaller, remember I took it to the ground. It was wonderful. Those are the two little circuit areas we're going to bring up on the breadboard now. Okay, we'll be over there for a while.